Picture this. You type a single sentence, hit enter, and an entire AI production crew goes to work. We're talking slicing footage, finding the exact rhythm in a music track, and editing a beat-synced video flawlessly. So the big question we're looking at today is, can an autonomous AI crew actually pull this off from scratch?
Well, the answer is an absolute resounding yes. Meet the VideoAgent system. It's this truly fascinating leap in artificial intelligence that is completely revolutionizing content creation as we know it. And today, we're going to unpack exactly how this works, not just as some abstract concept, but as real, functioning code. In this explainer, we're going to completely demystify VideoAgent. I want you to think of this whole system as your very own autonomous AI production crew. But, instead of a director and an editor drinking all the studio coffee, you have these highly specialized AI entities just waiting for your call to action, right inside a Python environment.
Okay, so here's our roadmap for today. 1. The VideoAgent vision. 2. Decoding user intent. 3. Meet the agent library. 4. Blueprinting with graph planning. 5. The textual gradient optimizer. And finally, number 6, executing the final cut. Let's dive in.
Now, before we actually get into the code, let's make sure we're on the exact same page about the core technology driving this. VideoAgent is built on what's called a multi-agent system. This is essentially a digital ecosystem where specialized AI entities act independently, but they work collaboratively to plan, act, and reflect on really complex tasks. So it's not just one giant AI doing everything, it's a team of specialized AI workers passing tasks back and forth exactly like a real production crew on a movie set.
All right, part 1, the VideoAgent vision, or the AI studio setup. So how does this magical digital studio actually work?
What's really incredible about this system, which, by the way, was built by developer Sana Hassan, is that it isn't just some theoretical concept. This is a highly accessible, lightweight Python environment. It's literally designed to run locally on your machine or right in Google Colab. And here is the absolute best part. It works even if you don't have expensive API keys. It has deterministic fallbacks built right in. The heavy lifting for the media is powered by open-source heavyweights like FFmpeg for video processing and Whisper for transcription. And when you do want to plug in an AI brain, it uses a unified wrapper that supports all the big players: OpenAI, DeepSeek, Anthropic, Gemini. It is a completely flexible studio space.
Moving on to part 2, decoding user intent. Going from prompt to action. The studio is built, right? But how does the system actually understand what you want to create? Every great project starts with a prompt. Just look at the actual system prompt given to the AI here. You are VideoAgent's intent parser. Decompose the user instruction into the minimal set of required capabilities. It's literally taking your natural language, say, make a highlight reel of the best moments, and strictly forcing the AI to translate that into actionable, technical JSON code based on a predefined list of capabilities. It's such a fascinating peek under the hood at how human creativity is mapped directly to machine logic.
And this brilliantly illustrates the sheer depth of the AI's logic. The intent parser doesn't just blindly read what you explicitly ask for, it extracts implicit needs. The source material points out that if you simply ask the system to answer a question about a video, the AI automatically knows that to answer a question, it implicitly needs to extract the audio first and then transcribe that audio. It thinks a few steps ahead, just like a world-class assistant director would.
Which brings us to part 3, meet the agent library, featuring 16 specialized experts. Because now that the system knows what needs to be done, well, who's going to do it?
This right here is where the magic really happens. The agent registry is basically a roster of 16 highly specialized digital crew members waiting for their instructions. You have the audio extractor pulling the sound, the transcriber writing down the dialogue. There's a rhythm detector that actually finds the energy peaks and cut points in the music. You've got a scene detector, a captioner, a summarizer, a video editor, literally an entire production house in a few lines of Python, operating at lightning speed.
To really understand how they work together, we just have to look at the system's code dictionary. Every agent has defined inputs, outputs, and capabilities. For example, the transcriber needs an audio path as its input, and it outputs a transcript. The scene detector takes a video path and outputs scenes. So the crew members just pass these specific data files to one another. It's a perfect digital assembly line where one agent's output becomes the exact input the next agent needs to do their job.
Okay, part 4, blueprinting with graph planning, building the blueprint, because now we have to figure out how do we actually schedule all of these inputs and outputs.
The system absolutely needs a blueprint to connect all those inputs and outputs we just talked about. And VideoAgent actually has 2 ways of doing this. The first is a deterministic, naive plan, which is a fallback that just wires basic inputs directly to the final terminal agents. It's simple, it's reliable. But the second way is where it gets highly intelligent, the LLM drafted plan. Here, the system uses an AI to look at your specific instructions and dynamically draft a completely custom node graph, picking the absolute minimal set of agents needed. It essentially draws up a customized production schedule right on the fly.
Part 5, the Textual Gradient Optimizer, or the Graph Optimizer. Now, you might be wondering, what happens if that AI-drafted schedule has a massive hole in it?
I want you to think of this Textual Gradient Optimizer as the ultimate automated project manager. It steps in when the initial blueprint is flawed. By definition, it assesses the graph structures and actually uses natural language edits to repair missing dependencies or fix cyclical loops, like 2 agents infinitely waiting for each other. It's the fixer. It ensures the whole shoot doesn't fall apart before it even begins.
Let's actually walk through exactly how this optimizer works, step by step. First, it assesses the graph by calculating specific metrics to check the chronological order, intent coverage, and data flow. If it finds a structural hole, step 2 is just incredible. It emits a natural language edit, sort of like a human manager saying, hey, we need to insert the audio extractor to supply the audio path for the transcriber. Finally, in step 3, it mathematically inserts those missing producers or removes loops until it converges on a completely perfect, flawless plan.
And that takes us to part 6, executing the final cut, action and wrap. The plan is flawless, the crew is ready, and it is finally time to render. So, when the code finally runs, it uses what is technically called topological order execution. Basically, it ensures a seamless, strictly chronological assembly line. In plain terms, the video editor agent is mathematically blocked from doing anything until the rhythm detector agent has fully finished its job. No crew member can jump the gun here. The execution is perfectly synchronized.
So the absolutely crucial point here is this. All of this complex Python code, the graph planning, the agent libraries, the optimizers, it all results in this incredible autonomous pipeline. At the end of the execution, VideoAgent can automatically answer complex questions about a piece of footage, it can summarize its entire transcript, generate a complete new style overview, and yes, produce beautifully trimmed, beat-synced edited video artifacts, all without you having to touch a single timeline.
We've honestly just scratched the surface of what a multi-agent system can do with video here. We've gone from a simple text prompt to a fully rendered, intelligently edited media artifact. So I'll leave you with this final thought to take away. When code can independently plan a project, act on those plans, and reflect to fix its own mistakes, what will you direct your autonomous AI crew to create next?